We got a new camera. Very excited about it. Shoots very good video. If anybody's in the market for a video camera, I'm going to caution you. Tech support on these things is less than optimal. I'm having a hard time. It records in a proprietary Sony video format. So you have to download their software to get it off your phone, which I tried to do and the download hung. So I called tech support and I'm like, okay, so now I'm pissed. We just spent $400 on this camera and I can't get the movies off. Now granted, they were like 2-minute movies of me filming my kid running around just to test it out before I got here to class yesterday. And I was like, I want to know how to switch this thing over to MP4, which is the file format that the rest of the world uses besides Sony. And he asked me, is it charged? I'm like, yes, I'm not 5, it's charged. Is it plugged into your computer? I'm like, dude, tell me how to get your freaking program onto my computer. And he disappears, puts me on hold for a while. While I'm on hold for 5 minutes, I put him on speakerphone. I'm like, to hell with this. And I get on Google. I figured out the problem for myself. Got a solution problem for myself. He came back, and he's like, man, I've got my boss on this, his boss on this. I can't figure this out. I'm like, I'll tell you what, I did. So get an audio recorder out, and I'm going to talk you through it. And that way, when somebody else calls in, you play my voice for them, and then send me a commission. And then I hung up on him. So anyway, if you're in the market for a video camera, there's some annoyances that are going on with these things. First of all, you can't delete off of this. Like when I did what the GoPro was, I record your classes, take it to the computer, plug it in, opens up as a hard drive, drag and drop, just like we've been doing since 1994, drag and drop the files over the desktop, rename them and upload them to YouTube with descriptions. You can't drag and drop. You can't delete. All you can do is copy them over, and then format the drive to wipe it clean. Genius. What year is this? 1978? Can't erase a hard drive? Sweet, good lord. And the guys at Best Buy were great too. They're like, when you record, save the battery life by keeping the little screen closed. As soon as you close it, it turns it off. It's like nobody knows the products they're selling anymore. And the people on tech support don't understand how to fix their products.
They're like India or something.
Well, I mean, regardless, you should know what your tech support, for goodness sake, your tech support. Support your tech. Not to keep it G-rated in here, but you know, come on now. Seriously. Anyway, so that's that. Got a new camera. The videos do look good, and I'm trying to record them in clumps so they upload more quickly. I think I've got it now. We got the bandwidth figured out. I upload them at night now when nobody's around, which seems to have the bandwidth is freer, so I tend to get them uploaded more quickly. I think last week your guys' class was okay. I think. I lost some videos last week at some point in the upload process, but I think I got all that figured out now. I got the camera. Is it going? I think it's going. Yes, it's recording. Got the extra big battery so we can go all day without... You can't plug it in to charge while we're using it, which is... There's no button. It's so weird. I'm like, where's the on button? They're like, there is no button. I'm like, well, how do you turn it on? You open the screen, okay? Like, I want buttons. I'm a child of the 80s. I want buttons, like fast forward and rewind. Whatever. Administrative stuff, week 2, welcome. How's week 2 going? Going okay? Class is going okay? Yeah, getting through it? Good, yeah. I put 2 quizzes up for you guys for Thursday. Do either, both, or neither. Your choice, right? You can do one or the other, or both, or neither. One's just a review quiz. Look at some of you guys have printed it already. That's totally rad. You don't have to print it. Remember, you don't have to if you don't want to. You can do them on scrap paper. It's totally fine. Just make sure it's neat and I can understand them. You can print them, of course, if you want to. The other one is on your first homework assignment. The other class worked me through this already. There were a couple errors in what I asked you to do in your homework assignment. I had included some stuff in there that I wasn't supposed to. So if you guys got to some questions where you were like, what the hell's a box plot? The box plot question shouldn't have been in the homework. I missed that when I was setting it up. So if anybody got, you know what I'm talking about, the one that says, look at the box plots, I fixed it. This morning I went through and found the errors and struck the ones that shouldn't have been there. So the ones where it said draw a bar graph after you had done a histogram, that was confusing the heck out of people, so I just struck those. And I struck the box plot one. There was one that said use a random number generator to select some states. Apologies. I gave you a link to one now, so granted, worst comes to worst. If you need a random number generator, just go into Google and type random number generator. And random.org? Yes, yes, very nice. Random.org, yes. I linked it to you there, so you just put in a small value and a high value, press generate, it gives it to you. But in case you don't know how to find one, I got one there for you. So apologies for that. This is going to happen every once in a while with a new textbook. Just me working through it, especially with this first assignment because it's so all over the place. Especially with the first one. So apologies for any confusion that caused. I do apologize. Do you have any questions that you want to go over from that assignment? So when I assign homework like I did last time, the first thing we'll do is ask you guys what questions you guys have from it. Did anything give you grief that you want to chit-chat about? Hopefully it did. Hopefully there's some discussion that we can spur from it. So what do you got? Here's the book. You give me a page number, I'll go to. You give me a problem number, we'll look at it. I don't even know we're all over the place. I'll wait for you guys to tell me where to go. Please!
Exercise 2.13.4.
Awesome.
What page it's on.
Don't know the page? Let's find that too.
It's just how to set up the histogram.
Not a problem. Let's figure it out. This is Richard, right?
Robert.
Robert. New week. Gotta read our names again. Alright, schedule 243. Stat. You said 213, Robert?
Yeah, 213.4.
Number 4, this guy right here, the 4 ABC. Okay, this is something I fixed. I think it used to say all but D, but part E was also giving people grief. Because it was a bar. Here's why I struck it. The first part of the question was create a histogram, and the last part E, was make a bar graph. And honestly, the phrase bar graph in industry does not mean the same thing to 3 different people. It means very different things. Histogram means pretty much the same thing to everybody. But a bar graph is very, and your authors are perfect examples of this, where they actually don't use the word bar graph the same as I use it. So I just took that one out. But let's do A, B, and C at least, Robert. So we're on page, looks like 88. I think I have to type in 98 to get that. Yep, there we go. So we're looking at this guy out here, the 600 adult Americans right here?
Yeah.
Awesome. So, okay, so it says we asked 600 adult Amerians, were asked by a telephone poll. How do you think those telephone numbers were generated? What do you think? What do you think? I would hope so. Random digit dial. Does it say that up there?
No.
It doesn't, but I'm going to assume time done by a third-party survey company used some kind of a random digit dialing. So maybe they did a stratified cluster where they said we're going to get a proportional number of New York and Delaware and Oregon and Texas. But we're going to assume they did a nice random sampling of that. 600. Does that bother anybody? 600?
It's a little low.
Seems too low. It is a little too low for my taste too. More on that in a moment. But we're not here to pick about that yet. We'll come back to it, Robert. Thank you. The results are below. Okay, here they are. And they asked them, what do you think constitutes a middle-class income? So 0.02 said less than 20,000. 0.09 said this. What are these?
Percent.
Yes. Yeah, relative frequency is another name for percent. I don't know why. I tend to use the word percent. Statisticians tend to use relative frequency. It's all good. It all means the same thing. So 2% said less than 20, 9% said that, 19, 26, and so forth and so on. 1% said 100,000 or more. It says also include a left endpoint, but not the right endpoint. We'll figure out why in a minute. Not sure answers were omitted. Okay. So A, what percent answered not sure?
6.
6.
I hear a vote for 6%. Tell me why it's 6.
That's what's left out.
Oh, good. So what you added all those up. So we got 2% said less than 2. That's 11. What's that? 30, 56, 74, 91 plus 3 is 94. 6% left over. Boom. There we go. So 6%, assuming there isn't some other choice like failed to respond or chose not to respond. If not sure was the only other choice, then yeah, 6%. I'm going to go with that one. Cool so far? Another apology too. Apologies for not having the camera working before yesterday. My plan was to have all these questions without solutions answered for you over the week. I was going to record them on Friday and I'm all uploaded, but then I couldn't get the damn camera to work. So apologies to have these. I'm going to be more timely now that I got the thing working. Okay, we'll come back to that, I think. What percent think that middle class is from $25,000 to $50,000? All right, let's go back up and look at that. What do we think? What do we think?
63.
This is Jenny. Jenny and Skylar. I wasn't even close. I was thinking 4 letters with an E on the end of it. Jenny and Skylar E. So 25 to $50,000? What do we got? I'm guessing these three? So 25. This is a little bit goofy here when they have the 25 shared in both, but I just count this one down here. So 19 plus 26, what's that? 45, 63%? 63%? Is that good?
Yeah, I think the question was kind of generic. You could have put 0 too because of the range. I mean, that's what I put. It could be 0% because the range, it seemed like you were saying 25 to 50. Well, nobody up there thought 25.
Oh, so how many would have given a range of 25?
That's what I thought.
I see what you're saying. That's a perfectly valid way of interpreting it. I think what they were saying was, given the mutually exclusive categories of those groupings, how many gave a response within? I like what you're saying though. I'll phrase, if I ever ask you something like that, I'll phrase it different. I'll say how many respondents, what percentage of respondents gave an answer between $25 and $50,000?
Yeah.
I see what you're saying.
Yeah, because it just said from, so I was like, well, wow, I could interpret that.
Exactly, you could. I think that's what they were hitting at though.
Okay.
So 63%. That's a good sized chunk, yeah. That's like 2/3 of them ish, somewhere in that ballpark. Good. And last but not least, part C. Like I said, I told you to dump out part E and F, or E and D. Construct a histogram. We'll do that in a second here. Should all bars have the same width based on the data? Why or why not? Now it says based on the data, and we're shaking our head. Tell me your name again.
Kate.
Kate, thank you. That's right. Why not, my friend?
Because the ranges aren't even the same.
This is a problem I have with some of this media research. They come back with you and they give you the data like this. And it's hard to notice at first. Those gaps aren't the same gap. First gap is less than $20,000. So assuming that it starts at 0, goes okay, that's $20,000. Then it's 20 to 25,000, that's 5,000. Then it's 25 to 30, 5. 30 to 40 is 10. 40 to 50 is 10. 50 to 75 is 25. 75 to essentially 100,000 is another 25. So I mean, that, and then 100,000 plus, Lord only knows where that goes up to. So, in my opinion, if I was presenting these data, I would do it maybe in $10,000 increments. 0 to 10, 10 to 20, 20 to 30, and so forth and so on and so forth. I do it though, and we're stuck with that. Why? Why can't we just force it to be the same distance apart?
Because we don't know the data points.
That's right, Skylar. Like, for example, I might want to take 30 to 40 and say, to hell with this. I'm going to break it to 30 to 35, and then break it to 35 to 40, so now I have 2 5s. And that was 26, right? So I'm going to make it 13 and 13. Can I do that? Can I do that?
Yes.
Should I do that?
No.
There we go. That's the correct answer. Please, CJ.
JC.
JC!
Okay. So do you think based on this problem, so it's based on income, so do you think that...
Perception of income.
Perception of
Yes.
income, yes. But like the ranges, because some people, I don't know.
Go ahead. Give us on your mind, my friend. Give us on your mind. I love it. I love it.
Because when I was thinking about doing this problem and doing a histogram, because the bars like aren't going to be
The same.
width.
Yes.
And I was thinking, well, why? Because but this is the perception of income, and it needs to be those. I don't know. When I think of income, I think it is very split, like middle class, high class, low class. So I think this, in my opinion, it sucks to do a histogram for it like this, but I think this is a good representation.
I agree with you, with both of those statements you said. And I think, let's actually draw, no, I agree with you wholeheartedly, and I'm not saying that we're right and anyone that thinks differently is wrong, I'm just saying that's our perception of, I think there is a great deal of variance, which is the next topic after today we'll talk about is variance. But let's actually draw this histogram and see how it emphasizes exactly what JC is talking about. 100%, my friend, 100%. Down here it says, how should these be handled? Although I think we talked about this one already. Less than 20,000. Well, there's a bottom of that, right?
0.
I think 0 is a logical place to put that one. And then 100,000 plus, we'll deal with him in a minute. I know it told us up top, it said not the right endpoint. There's a graphical way of dealing with that you may or may not have seen before, so we'll deal with that today. I'm going to mute this and refer back to it over here. I may have to, oh wow, that's all right, R2. This is like the weirdest room ever. It's got a powered screen, but not one of those cool, like, droid neck things. Okay, does anybody have this in front of them? By any chance? No, I'll just call it. Actually, why don't you guys call it to me? No, come on, so. Damn it. So we're doing number 4, correct, Robert? And this is in section 213.
213.
Part number 4, part C. That's exactly correct. All right. Now, in all honesty, you would do this in Excel or some kind of a computer program if you were going to submit this to somebody. And the reason why that's so nice is because they scale everything for you perfectly. See, now what we have to do is we have to kind of do this. We have to do a set of axes. And then down here, we've got to give it title. We've got to give the chart a title, which I think JC's given it to us, right? Perception of income in the quote-unquote middle class.
Might want to move your camera.
Oh, is it not catching it? Thank you. Thank you. It's not. Look at that. There we go. Maybe tilt it down too. I should invest in a GPS chip
I
like I was
love
talking
the
about.
duct tape.
Well, yeah. I got here and I realized that yeah, I'm a punk rocker. Duct tape, baling wire, JB Weld, there's all kinds of things that work really. So, anyway, twine, yes, many little tricks. We got to break this axis up into some logical increments. I'm going to go ahead and slap 100,000 out here. And I'm going to do it to save us some space. We're going to put down here, it's income, right? Yeah. I'm going to put income in thousands of dollars. That'll just save us some space on the horizontal, so we don't have to worry about having so many zeros on there. So 0 would definitely be here. I'm a big fan of having 0. Let's put here 0. You don't have to have the dollar amount, the dollar sign, because you're putting it down here. And now we can break up the axis into pieces. So here's, let's see, 50's about right there.
Does it
About,
have to start with 0?
Well,
Some of them don't.
no. This is a great question Scott was posing. Does it have to start with 0? No. Nor does the vertical have to start with 0. As long as you're representing your data, you're fine. Why do I like it to start with 0? Why do I like it to start with 0? I'll put that question back to you guys. Why do I like it? It keeps the number line in perspective. The number line is a continuum. It starts technically negative infinity, but there is no negative infinity salary. So you start at the minimum possible value, which is 0, and you work up from there. That way we know that 100,000 is exactly twice as far away as 50 is. If you don't start at 0, that relative is lost. Is that fair?
Yeah.
Dollar amounts, income, are what are called ratio levels of measurement versus interval. And if you include 0, all of a sudden you're like, oh, 50 is half as big as 100. 25 is half as big as 50. It's a quarter as big as 100. So having that 0 there, you know in your mind that 25 is half of 50. But your mind can be tricked by your eyes if it doesn't see that. And we've seen that happen all the time, optical illusion type things. Like these circles are the same size, but this one looks bigger because of perception. So that's why my vote is to keep it at 0. 75. I think we can get everything we need off of there. So that's going to be the income. Over here will be the percentages. The percentage of perception, I guess we'll call that. Percentage of perception. Almost sounds like a bad 80s band. Perception. Speaking of the 80s. And what should those percentages go up to? Let's see. 26 is the highest, yeah, Nat?
Yeah.
Oh, let's make it go to 30. That way it gives some wiggle room.
Yeah.
I don't like, and this is back to Skylar's question, when I'm making these graphs, I don't like the highest bar to ceiling out. I like to have some wiggle room so it doesn't look, again, like you're trying to hide something. So we'll go to 30. 0.3. Let's break it up by 20s maybe, or by 10s, excuse me. So far? Am I happy with this? Or at least content? It's math. Let's be realistic. But he's happy. Cool, let's do it. So the first one is less than $20,000 has to go to 2%. So 20,000, here's 25,000. How far down should I come down to get to 20,000? 20% of this range, correct? It's got to make up 80% of this range. So we're going to call it like here. And that's going to go to 2%, which is going to be 5, 2.5. That's about right. I'm going to call that 2%. And this is my personal opinion. You do not have to agree with this at all. I like putting the individual data points on top of the bars. I found, and part of this comes from the fact, and you'll see this a lot in this class, I use a lot of Excel simulations in here to kind of drive points home. and it's nice having those dynamic numbers changing in class. So I've gotten kind of in the habit of drawing those. Color the bars in if you want to. What do we got next? 9% into 20 to 25,000. And finally, JC, I think we're going to start seeing what you're talking about over there, my friend. That's about up to here, right? There's 9%.
I have another question.
Please!
So in the book, like in the reading, it said, it like went through this section of how to give it different widths.
Don't worry about it.
Don't worry.
Don't worry about it. It really more or less is the author's opinion on how to do that.
Okay.
Yeah. And what I need to do is go into the reading part and take that out as well. I know I need to get in there and pull that out of the reading as
That was
well.
actually confusing.
It's very confusing. And the problem is you're making assumptions based on data that you don't know anything about.
Right.
So don't worry about that. Just
Okay.
the reason I was so surprised because the other class really was ready to string me up yesterday. Because like, how the hell do you expect us to do this? And I'm like, what? I just wanted you to take that distribution and draw a picture of it. And they were trying to go through that. I didn't realize was in there. And all I wanted to do was just do this. Just do this. We'll say that again.
You didn't read it?
No, I read it, but I read it briefly as I was going through it. I mean, the thing's 700 pages long. I read it as I was going. Oh, yeah, histograms. Yes, check that, check that, check that. Yeah, little light toilet
Just
reading.
tell them it's learning. It's learning.
25 to 30 is 19, so that's going to take us out to about here, I guess. That's up to. Ooh, pretend that's straight. A little bit more. Sure. Again, pretend that's straight too. Good Lord. 19. There we go. Now we've got 26 between 30 and 40. So we're going to come out to about here, I guess. Ish. This is beautiful. 18, 40, and 50. 18 comes to maybe here. And you're starting to see the limitations of my artwork. These should be the same width because they're both $10,000 wide. So, yeah, we'll just cheat a little bit. Just do this. There we go. Ish. We get 17 from 50 to 75. This is one of my favorites. That was 17, not 15. Which means it's higher too. Two from 75 to 99999, which I'll just go all the way up to 100 because at that point it's fine. And last but not least, 1% in the 100,000 plus category. So how do we deal with that? How do we deal with that? How is that dealt with sometimes when you see these kinds of graphs in the news when you don't have a top point? What do they do to the axis? Do you remember ever seeing this in graphs? Yep, you can do the arrow, that's the mathematical way. You can put a split there like that. That indicates that it keeps going. The arrow is a perfectly mathematical way of doing that, Nat, absolutely. I'm going to move this over a little bit, actually. A little bit further. Put the split and then put the arrow. And you can even arrow the bar if you want to. Just show some indication that it keeps going. Just some indication that there's no top end on that. I mean, obviously there is. One of those 600 people gave the highest income for the middle class, but it's not indicated as to what that is. So it's goofy to look at, isn't it? It is goofy to look at with the whole stretching of the bar. But I think JC hit the nail on the head when she said, yeah, but it also talks about the variance. Look at what happens. With the exception of the under 20,000, what happens as we go left from here? What happens to the bars? They get much bigger, wider. Meaning the results that are being given are more varied. So the perception of a sizable chunk, I mean right in here, what percent are in here? What percent are in here?
Over half.
That's 30, yeah, well over half, right? Yeah. 63 plus that 18 that we have to add in from before. So roughly 80%. Roughly 80% of the survey gave us in that very, very tightly clustered 20,000 to 50,000 range. The other 20% either under or overestimated. Go ahead,
So
Jim.
that's your answer.
It's one of many answers, right? Because the question was just to draw a histogram.
Yeah.
And then what do we get from it? I think we get so much more than just a histogram. We then get the idea of variance, the wider bars, the bigger bars. We know that yes, the answers were all over the map from under $20,000 to more than $100,000, but to think that Americans are split evenly from under $20,000 to over $100,000 is ridiculous. It's clear to me that 80% of Americans think it's between $20,000 and $50,000. Assuming this was a random sample. We're making a big assumption about the sample, right? Big assumption. Speaking of which, 600. We think it's a little too small? It is. It's a smidge small. You have to accept, I think we've talked about this before, a margin of error on that sample because of that. Margin of error because of that. With a sample size of 600, I think you have to accept somewhere between a 4 and a 5% margin of error. Which means those percentages that you see, the 2, the 9, the 19, the 26, they really aren't 2, 9, 19, 26. They're 2 plus or minus 5. 9 plus or minus 5. 26 plus or minus 5. And the problem with that, of course, is depending on whether it's plus or minus and how far plus and how far minus, what we just called 80% might be 70%, might be 90%. Conversely, that 1% over there that said more than 100,000, that could be 6%. And that seems kind of terrifying to think about, that 6% of Americans would think that the middle class makes 100,000 or more per year. That's a little terrifying, right? A little scary. But with a sample size that small, you kind of have to accept that kind of an error margin. Is error a bad thing? I'm using this word error. Is that a bad thing?
No.
It's not a bad thing at all. It's a necessary thing. Because you did not ask every single one of the 310 million Americans. You asked 600 of them, and you have to put some plus or minus. Isn't it amazing that with 600 asked out of 310 million, all you've got to add is like 5%? Isn't that crazy? 244 didn't believe it this morning. Like, it's crap! And I was, well, here's why. You're like, okay, I still think it's crap. Like, they still didn't quite buy why it was okay, but mathematically it flushes out. In much the same way that this crazy range of values chops down to 80% right here, that crazy range of 0 to 100% error chunks down to a very small margin which traps most of the results. Robert, you have a question? I thought I saw a hand go
I
up.
was just wondering if anybody ever tested that, like called every single person, you know, if you did a huge...
You'd never be able to. The closest the government tries every 10 years is the
The
census.
census.
And even they've given up on that. They're like, you know what, this is ridiculous. And it is ridiculous, because the census was put into work, what, 400 years ago, and there were like 22 people living in the country? Go out and meet your neighbor, and the other neighbor, and then call it good and send us in the results. I mean, now there's 310, and you can't ask every... I didn't even mention the word census on the first day of class. That's what it's called when you go and audit every single member of the population. It's ridiculous. It's impossible because the population, especially of America, keeps changing. I mean, in the time I've been talking, somebody just died, and 2 more were born. I mean, think about that. Think about that. You're going to go track them too. It just becomes exhausting. Now you can get larger samples, Robert. If you double your sample size. As a result, actually, if you quadruple your sample size, I get the math in my head here, right? If you quadruple your sample size, you have your margin of error. It's actually kind of cool if you think about it. So if you go from 600 to 1200, whatever the margin of error is on this, shrinks by half. Now, because it only shrinks by half, it'll never shrink to 0. It'll keep taking half of half of half of half. But essentially, it eventually gets so close to 0 that it's essentially 0. It might shrink down to 0.1%. At which case you're like, I don't even know what 0.1% is. Is that fair? And I'm getting into some 244 stuff here, but still, nonetheless, you can do math with a sample of 600. But the big focus on this, I think JC nailed it with the discussion of these widths, and Jenny agreed with that, with the difference in the widths versus the heights. The heights tell us something, and the widths tell us something. Very, very, very cool, actually. It's kind of fun to look at them skewed like that. There's no rule that says they have to be the same. That's why I don't like that section of the book that tells you have to fit them into the same equal bars.
Oh gosh,
You don't have to. You can use this. This is totally fine.
yeah, that seems impossible.
It's okay. It's okay. Given the choice, I like to put the data to you in even intervals.
Right.
But this was given to me, so I've got to deal with it as I have. What else we got? What else you got in there that gave you grief? I think look at myself. Now that I've talked to you guys about that, I want to cut that bit about the histogram adjustment out. And I love it too, Jenny, what you said about, did we answer the question? You said something about the question. And that's what's so interesting about this is there's no question, but there are implied statements, right? There's not a question one up here, but you get a really, really neat picture of the responses in this, and it's neat. Like, you're going to learn soon enough that this is roughly bell-shaped. Or maybe you've already learned it, depending on if you've taken psych classes or social classes. Why would it be bell-shaped? Who knows? It just is. And it's interesting how many things do that. Everything from perception of middle-class income, to the lifespans of that battery in that camera, to the runs of, I took a CPR final exam with Jenny last spring, right? Got $100, don't brag, right? But it was a multiple choice, A through D, and I was taking the exam, and the first, it was A, and I started grinning. And I started looking around the room, and there's all a bunch of kids in there with me, and they're freaking out. Because Jenny's like, you take this one time. If you don't pass it, you wasted the whole day. And it's like, A, and I'm like, this is great. And the kids are like looking around at each other. Oh my God. And then it was like B, A, C, D, A. It was all these runs of letters. And I thought it was interesting. And she didn't make the exam. The American Heart Association made the exam. But I thought it was interesting that there were all these clumps. So I created a statistical test to test the clumpiness of multiple choice exams. And as it turns out, the clumpiness is bell-shaped too. You actually graph clumpiness in random exams and it's bell-shaped. I mean, where does this bell come from? I don't know, we'll spend 10 weeks discovering it. But clumpiness and watching those kids freak out was worth it. That was good. Are you getting B? Yeah, okay. You can be again. Shit, I got 4 weeks in a row. It's great, absolutely great watching them freak out. I mean, they all passed though, so it's good. What else we got? Anything else in there give you grief? Please, Skylar.
On 14, I think it's the same section.
14, same section. Let's scroll down.
It says to scale it by 50, but the increments they give you is only 49.
Well, let's figure it out. Is it this one here, the singles and couples?
Yeah.
Oh, and I also chopped quite a bit of this problem off. I apologize. This is one I was looked at today as well. I realized that I had given you like 18 parts of this problem. It goes like A through G or something. And that's a little silly. Cruise ships conduct all on-board transactions. Let's pull this down a little bit. With the exception of gambling, on a cashless basis. At the end of a cruise, guests pay one bill that covers all. Suppose that 60 single and 70 couples were surveyed as to their onboard bills for a 7-day cruise from LA to the Mexican Riviera. Below summary of the bills. Here we go. All right, so here's the amount they spent. Here's the frequency of that occurrence. So it looks like there were 5 single people that spent between $51 and $100, 10 between 100 and 150, and then here's the couples. It's kind of clever. So it's almost doubled, which kind of makes sense, I guess, if they both spent the same amount of money. Okay, and they fill the relative frequency for each group. We okay with that? The relative frequencies, solid, just percentages, right? Let's just discuss it verbally though. If we needed to figure out the relative frequency of 51 to 100, relative frequency again is just another word for percentage. How could you figure that percentage, the relative frequency or percentage for this group? You got to take 5 divided by 60. About 8, a little over 8%, right? You got a good 10 divided by 60, a little over 6, about 17% and so forth and so on. That's all you do there. Construct a histogram for the singles group, scale the x-axis by $50 widths, use relative frequency. So Skylar, your point is that, so go ahead.
Well, it was saying they gave you 51 to 100. Isn't that scaling it by 49?
Actually, that's 50. And here, this is something you have to get used to statistically. Very, very good. There are actually 50 numbers between 51 and 100 because you have to count 51 as the first number. So my gripe is with that one. There's actually 51 right here. That should be 101 to 150. But don't worry your head over it. It's minor. Again, all I wanted you to do was take this and turn it into a histogram. That's all I was after for this problem. But don't worry yourself. Does that make sense, first of all, friends? That there are actually 50 numbers here? It might be harder. Don't do that. Imagine if it said 51 to 100, imagine it said 1 to 5. How many numbers is that? It's 5. 1, 2, 3, 4, 5. Right? But 5 is 4 bigger than 1. But you have to count 1, which we never do when we're doing addition and subtraction. You subtract one from the other and you give the result of how much bigger the one is than the other. But you gotta count that first one, Sharon. Good.
I know this is really probably basic and simple.
Go ahead.
Why is it that you divided it by 60 to get the percentage?
Oh, because of what they told me up top, which we may have forgotten. If you go up to the top here, it says there were 60 single travelers and 70 couples.
Okay.
So the percentage of the singles, does that make sense?
Yes.
Oh no, all the math in this class is basic. Never feel bad about asking it.
I was like, okay, wait a minute, I didn't.
No. It's all about processing what's coming at you. That's what it's all about, is processing it. Question. If we summed up this column right here, what would that sum to? It would be 60 if they got all the data correct. And if we summed up this column right here, it would sum up to 70. This data looks completely bogus to me, by the way. These fives. If we summed up this column right here, assuming we did our math correct, it would be
100.
good, 100%, or just 1, depending on how you choose to do your decimals. And then how about over here?
100 or 1.
100 or 1, depending on how you choose to do your decimals. That's kind of the benefit of relative frequency versus raw frequencies, depending on what you want to look at. Relative frequencies are more easily scaled because they're out of 100. Please, Jen.
Okay, but there was a problem above that after the relative frequency, it was the cumulative relative frequency.
Yes, and I hope I told you to skip that.
No. Oh, shoot.
I did or I didn't?
I know, we did it.
Well, I'll fix that too.
Because I didn't know what that
Yep,
meant.
don't
It was like the first problem, it was like number 3.
I will fix that. You don't worry about that. I want you to worry about that, but not now, 3 weeks from now.
Okay.
We're going to talk about growth charts of 2-year-old white American males. And that's where we care about that kind of thing. We do not care about it right now. It's meaningless right now. I apologize for not catching it. Relative frequency.
Google is a wonderful teacher, though.
It is. It is. Google is the best teacher when it comes to all these terms. And that's how I solved the camera problem on hold with whoever it was. So yeah, I apologize. Though. I didn't want you dealing with that right now. It's different enough from a normal histogram. There's the box plots I shouldn't have given either. Damn it. Anything else? Scott, does that make sense?
Yeah.
We're golden now. Please, JC.
Can I have like a clarification?
Go ahead. Where are we?
The very first problem.
On the whole problem, the whole thing? And that would be
Number 1.
on 36. It's okay. I want to make sure I'm on the right page for you.
Oh.
This guy right here?
Yes.
Type of data. Let's do it.
Okay, so
Go.
F. The
F.
most watched television show.
Yes.
So my brain is thinking most, meaning number, but it says most watched TV show. So
TV show.
It's a TV show, but
So therefore it is.
The answer is the TV show.
The TV show is the data. What kind of data is it? It's qualitative. Wherever it is, boom, boom, qualitative. Good. I love the fact that you're saying it's the most watched, which means however they're measuring that has to have a number attached to it. But the data itself is a TV show.
So unless it says like number, like E above it says number.
Number of students enrolled, yeah.
So unless it says number or a specific like
Yep.
length or measurement.
Very nice. The data has to be numerical in order for it to be quantitative. Yeah, the data itself. The data can't be a name or a color or a vegetable or something like that, or a TV show. What do you think the most watched TV show of all time is?
Seinfeld?
Seinfeld, maybe?
Friends?
Friends? Perhaps,
The
yeah.
Flintstones?
The Flintstones? Magnum P.I.? No. Simpsons? Simpsons, yeah. But I bet you Simpsons is still running.
Yeah.
So, but then it depends on how you define most watched, right? I mean, The Simpsons has never stopped running since it came on, but Seinfeld ran for, what, a decade-ish, right? Friends the same, I think. Friends was like the 90s show. Seinfeld was a 90s show. The Flintstones are still doing reruns, as are Friends, and I'm assuming Seinfeld is too.
What about the ones that have been going for years that are still reruns? Like
Exactly.
Shirley.
And how about the population of those watching television? It's growing larger. A show that was watched in the 50s was seen by 300 million people, maybe. Or excuse me, 150 million people, maybe. Now there's 300 million Americans. How do you adjust for that? And I bring that up only because they talk about the top grossing films of all time. They always talk about the top grossing films of all time. Star Wars Episode 4. If you waited for cost of living changes, the first Star Wars, if you will, the first Star Wars, A New Hope, I think it was called. That is in the top 10 most grossing films of all time if you waited for inflation and other factors. I mean, any film that comes out to Blockbuster now is going to eclipse anything that was made in the 70s just because things are more expensive now. It made $500 billion in its first week. That's because you cost $45,000 to get in. In the 70s, you can go for $1, right? But if you adjust for inflation, Star Wars Episode 4 blows most movies out of the water, which is kind of crazy to think about, right? All those crazy lo-fi tech effects, and they're still amazing. So, but that's why I bring that up. The defining, how are you? What is most, right? Is it a strict dollar amount? Not fair, really. Not fair. Not really fair. Cool. Thank you, JC. Great question. Patrick, ask me that question.
In that, is there a different, in quantitative discrete or quantitative continuous?
Yes, yes, yes.
Does it have to contain one or the other? In other words, is there a quantitative answer? So in other words, when she was using an example earlier on in the home,
Sure.
she said distance between home and nearest grocery store.
Or, yeah, okay, good. Or this one here, closest movie theater. Perfect.
Closest movie theater.
Boom.
Because if you're living in Delaware, there's three
Sorry for
ways
you.
to get there. Yeah.
Right, go ahead. There's 3 ways to get there.
So is that quantitative?
Good. First of all, what is the data? Always ask yourself, what is the data? The data is the distance. It might be feet, it might be miles, it might be inches, depending on how close you are. But it's definitely a number, because it's a distance. You don't measure in orange or pairs. You measure in some kind of a numerical length of a ruler. And I just gave the answer, didn't I? Because I said you measure the distance. And that tells us what kind of quantitative it is. It's continuous, because it's now granted, there are more than one way of getting there. Google Maps, if you type in a destination in Google Maps from current location, it usually gives you 2 or 3 options. But each of those is a continuous quantitative measure to get from point A to point B, every single one. Yeah, so that's a good point, but it's still, every one of them is a measured. Let's just go through the list, shall we?
So in other words, sorry, Sean.
Oh, no, go Patrick.
I apologize. So
Don't apologize.
In other words, there will never be an answer that will just be quantitative.
I like asking you which is which, and the reason is, it's more for prep of the 244 students. It's to make you guys, how many of you taken 244? Roughly half of you, right? Oh, that number, I think I scared you off since day 1. It was more like half of you the first day. But I want you being able to know which tests to run and what to do with data. We'll start that at the end of 243. So it's important to know, am I counting or am I measuring? Am I going to use the binomial distribution or the normal distribution to analyze that data? So it is important to know, to classify them. Let's pick one. Age of executives in Fortune 500 companies.
That's the only one that got me.
Oh, it's the only one that got you! Well, then I'm glad we picked it at random-ish. Just happens to be at eye level. So, first of all, qualitative, quantitative. It's definitely a number, right? It's an age. It's an age. Beautiful. The tricky, I think the reason, Scott, I think you've nailed it too, the reason it's tricky is because when I ask you how old you are, generally you guys are going to give me an age in years, round to the nearest year. 40, 30, 20. But it's time, Kate, which means it's continuous. It's continuous. Your age, you're older now than you were when I asked you that question 5 seconds ago. And you're older now than when, this is going to turn into one of those goofy little things. But your age is continuous because you're measuring it. Yeah, we round it off, but it's still measured, right? Time, weight, length, temperature. Those 4 things, those are the continuous classifications. Anything else continuous up there? What do you think? B?
No, D.
D. Time in line to buy groceries. Yep, I'm down with that. Time in line to buy groceries, yep. Anything else? B. Say it again? B. Amount of body fat. I agree. How do you think body fat is calculated? It's weight. If you get your body fat analyzed, we do the total fat all the time. The percentage is a percentage of your overall body mass, which is a weight, which is technically a length cubed, but it's still a weight. So yeah, body fat, that's going to be continuous. Continuous. Anything else? We did that one, right? Anything else? But we did the age, correct? So here are your continuous ones. Okay? How about this? Number of tickets sold to a concert? That's definitely discrete. It's quantitative, but it's discrete because you're counting it. There's no half tickets, quarter tickets, third tickets. Favorite baseball team? Totally qualitative. There's not a number attached to that. Time in line, number of students enrolled at Evergreen Valley? That's countable, right? That's countable. That's discrete. Most watched, we did that one. Branded toothpaste? Qualitative, yes. Distance, we did that one. Distance to club movie theater. Age of executives, yes. Number of competing computer spreadsheet software packages. That's discrete. You count them. Excel, and everybody else trying to beat Excel. There you go. That's that. Yeah, please, Jay.
Well, the The second part says give an example of the data.
Oh, give an example of it. We just did. Number of competing computer spreadsheets. We got Excel, OpenOffice, whatever's on Mac, whatever just got invented 5 seconds ago. We're sitting here talking. So, yeah, that's okay. Amount of body fat would be 9%, 10%, 14%, 25%. Number of tickets sold to a concert, depending on what concert. If it's a concert at the Tower, maybe 120 tickets were sold. If it's a ticket to Fleetwood Mac at the wherever the hell Fleetwood Mac plays, maybe 10,000 tickets. Brand of toothpaste, Crest, Colgate, Total. Total, Crest, Total, Colgate, Total. But that's what we're getting at. That's all we're getting at there.
I thought it was harder than that.
Oh no. Just making sure you can identify this stuff. Let's take 5. You're getting that look. It happens.
It's called nauseous.
It's called not.